Let's record. Everybody say hi, Kenzie and Holly.
Hi.
There you go.
Nobody can,
Okay.
Kenzie and Holly.
All right. So I went through this first example, and I said that
Hi,
if we
Kenzie and
had,
Holly.
hold on, if we had a test result A, like this scenario here, what they're doing is they're talking about 100 babies born, and if 75 of those babies are born as a girl and 25 born as a boy, a 75-25 split is really huge. The chance of that happening randomly is 0.000003. Okay? If it is a less than 5% chance of happening by chance, then that drug is working. So whatever they're giving to these mothers to make it so that they have a 75-25 split, whatever they're giving to those mothers is in fact working, because the chance of that happening randomly is that 0.003, which is less than 5%. Okay? There is an 18.4% chance that we're going to have a 55-45 split. That's not a very big split. So even though there are more girls born than boys, a 55-45 split does happen quite a bit out of 100 babies. 18.4% of the time that happens. So really that drug probably is not doing anything, or not doing enough to put it on the market. Saying that we are trying to get, if we're trying to get more girls than boys, I probably wouldn't pay oodles of money if this is going to happen. I would pay oodles of money if you can guarantee me that that's going to happen. Okay? Yeah. All right, so an event, basic probability. An event is like a trial. Okay, so a trial of something. So an event would be, a mother taking this supplement and trying to figure out what gender of a baby they have. A simple event is only one thing occurring. I think occurring only has one R. Anyway, only one thing occurring. So a simple event would be like rolling one dice, okay, drawing one card. Compound would be rolling two dice or rolling two cards. So only one thing is occurring, okay? Sample space is the list of possible outcomes.
No.
Okay, so we list them out. What's the list of possible outcomes for rolling a dice?
I don't know.
1, 2, 3, 4, 5, 6. Okay. List of possible outcomes for flipping a coin.
1 and 7.
Heads, tails. What's the list of possible outcomes for flipping two coins?
Heads, tails, tails. Heads, tails.
Heads, heads. Tails, tails. Heads, tails. Tails, heads. Okay, that's flipping two coins. This is a compound event. Okay, simple event would be the heads and tails, right? Compound versus simple. Doing two things, doing one thing, yeah? Okay. I could make that even harder and say flipping three coins. Heads, heads, heads. Tails, tails, tails. Heads, heads, tails, blah, blah, blah. How many outcomes are there if I'm flipping three coins? Do you know?
Heads, 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 tails, tails, tails. Heads, heads, tails.
How's it not 9?
Tails, tails, tails.
Okay. Heads, heads, heads. Tails, tails, tails.
6, it's 12.
Tails, tails, tails. Okay. Heads, heads, tails, blah, blah, blah. How many outcomes do I have with the first coin? How many outcomes could I get if I'm just flipping one coin? 2 outcomes. How many outcomes do I get if I flip the second coin? 2. How many outcomes do I get if I flip the third coin? 2. Right? I could get a heads or a tails here. I could get a heads or a tails here, a heads or a tails here. So there are 8 total combinations.
I told you it was 12, Cody.
8 total possible combinations, right? 2 times 2 times 2. This is like the fundamental counting principle. There are 2 combinations for the first coin, 2 combinations for the second coin, 2 combinations for the third coin. Multiply them together. There are 8 total possible. Okay? Same thing here. Look at this guy. If I'm doing a single birth, I could get a boy or a girl. If I have 3 births, okay, the first baby could be a boy or a girl. That's 2. The second baby could be a boy or a girl. That's 2. The third baby could be a boy or a girl. That's 2. So I have 8 different combinations of children. Okay, so I have 3 children.
Well, you have 2, and there's 3 2s there.
3 children. I could have 3 boys. I could have 2 boys and a girl. I could have a boy and then a girl and then a boy. I could have a boy and then 2 girls. I could have a girl and then a boy and a boy. A girl and a boy and a girl. A girl and a girl and a boy, which is what I actually had. I had a girl, girl, boy. And I have a girl, girl, girl. Those are the 8 different combinations that could happen. Okay? So this is the combination that I had. Okay?
Yeah, how do you know that?
You're silly.
It hasn't popped
But there
out
are
yet.
8 total possible combinations. What? What are you talking about?
Gotta be exact.
Oh, no, she had a kid.
Oh, come on. Return.
Yeah.
How do I get out of here? Okay, there we go. So anyway, there are 8 combinations. All right. Anyway, so how many combinations would there be if I had 4 children? Heaven forbid I actually do that. But if I had 4 children, how many combinations would there be?
Do that to yourself.
I don't know.
4 children's not as bad.
16. I would take that 8 and I would multiply that by 2 again. So there would be 16 combinations.
Are you gonna have another one?
No.
Why?
4.
You got 2 more.
4 children. No.
Oh, 3 more. 3 more?
Okay.
I heard 3.
16 combinations for 4 children. So one of the combinations, listen, one of the combinations is girl, 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 girl. Boy, 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 boy. I could have 2 girls and then 2 boys. I could have a girl, boy, girl, boy. I could have a boy, girl, boy, girl. All of those combinations, there are 16 of them. 16 of them. Okay? Here is the list of all of the possible outcomes you can have for a probability. You can have a probability of 0, which is impossible. Like it is impossible that, I don't know,
Kaden is smart.
something's going to happen.
Example. You flip a coin.
It is impossible that if I flip a coin, I'm going to get a 7 to show up. Right? There's not a 7 on a coin, right? Okay, whatever. Impossible events. A certain event, okay, event that is why am I getting that? A certain event that is 100% likely to happen. 100% likely to happen. I don't know. Like 100% chance of rain, not today, but the meteorologist might say 100% chance of rain if it's already raining, right? There's 100% chance of rain if it's already raining. 0% chance, okay? A 50-50 chance or a 0.5 as a percentage chance is equally likely to happen as it is to not happen. So an equally likely chance would be a heads versus tails. Heads versus tails. Or a boy versus girl. There's a 50-50 chance. Don't go there. Don't go there. 50-50 chance of boy girl, 50-50 chance of heads tails. Don't go there. Okay? All right. Anyway, let's go down here. The probability of something happening is the number of times that it occurs over the total number. So they might say the probability of a king. Okay, if I have a deck of cards, the probability of a king happening. They will write it like this. This means probability of king. What are the chances of me having a king show up out of a deck of cards? 4 kings out of a total of 52, which if you reduce them is 1 over 13. Okay?
1 over 13.
When you do your homework assignment online, listen to this. When you do your homework assignment online, pay attention to whether they want it as a fraction or they want it as a decimal. If they want it as a fraction, they are not going to accept the answer 4 out of 52. They will count it wrong. Make sure that it is reduced. So you might come to me and say, "Oh, I know I did the right thing. I know I got the right answer, but it's not reduced." That's why they reject it.
Yeah, like
Okay?
I put the same answer in 10 times and then
Right.
it's like, yeah, you're right on the 10th one.
Yep.
Bruh.
Okay.
Bruh.
All right. I'm gonna talk a lot about this guy right here, the law of large numbers. Okay, the law of large numbers. So let's talk about flipping a coin. Flip a coin. Let's say I'm flipping the coin 10 times. Flipping a coin. Let's say we're flipping a coin 10 times. How many heads? How many tails do you think you're gonna get?
5.
5 and 5. You're
6
really
and
gonna
4.
get. Let's do 6 and 4. Sure.
7 and 3.
7 and 3.
Somebody get a coin.
Okay, let's do it. We have a coin. Okay, ready? Write these down. Somebody put a little tally. Just somebody.
I got it.
Heads.
Okay. It is tails. That one didn't even flip. Tails again.
Definitely heads.
It is tails again. That's 3 tails.
Heads has to be.
Tails.
Rigged. Yeah, this game's
The coin is weighted.
Heads.
Oh, we got 1 head.
Heads.
Oh, we
I
got
have a
another
whole
head.
bunch of heads right in a row. Tails.
Oh,
How many
we
we
got
at?
heads in a row. We got like
Heads.
4 tails in a row.
Tails.
Heads.
Whoa!
Wow.
Babe.
It is tails. How many we at?
6
4
and
heads
4.
and 6 tails.
6 and 4.
Woo!
Go call it.
4 heads, 6
No,
tails.
technically you said 6 and 4,
Okay.
so that means you meant 6 heads
Okay, 4 heads, 6 tails. Okay? Now, let's say we do it 50 times.
No.
Then you get.
Okay, hold
97
on, just wait a second.
What, you doing it?
If we do it 50 times, we're not going to actually do this 50 times.
Oh.
We have 4 heads, 6 tails, right? 4 heads, 6 tails. That is a 40% and a 60% split. Okay? If we do it 50 times,
You're gonna have 20 heads and 30 tails.
no.
No,
If we
you're
do
gonna
it 50
have
times, are you
one
likely to get a 20, let's see, a 20 and a 30 split?
No.
It's probably going to be closer than that, right? It might be closer to like 45% and 55%, right? Okay? Because a 20-30 split is pretty significant, right? Let's say I flip it 100 times. Okay? What is likely to happen to that?
50, 40 stuff.
Probably like a 47, 53 split. What if I do it 1,000 times? It's going to be maybe like 49, 51.
Why can't it just be
Okay.
50?
So, the more times you flip the coin, the closer it gets to what the actual values should be. So I'm going to write that over here. I'm going to say, let's talk about theoretical probability. Theoretical, write this down. Theoretical probability
I think it's spelled.
versus experimental probability. Okay, theoretical probability is what should happen. What's the experimental probability?
What actually happened?
What actually happens, right? So in theory, if I flip a coin 10 times, how many times should it come up heads and how many times should it come up
5 and
tails?
5.
5 and 5, but did it actually do that?
6 and 4.
No, it did a 6 and 4, right? Okay, so theoretical versus experimental. So the law of large numbers, here's what this guy says. The more trials you do, the closer the experimental probability gets to the theoretical probability. Okay, my experimental probability with each time that I increased the number of times I'm flipping the coin, it gets closer and closer and closer to that 50-50 split. Okay, right? Does that make sense? That's what the law of large numbers says. The more times I do it, the closer it gets to that experimental probability. Right? Good, good? All right. What do we get? Oh, we get a lot of stuff too. Okay, let's
Good place to
do,
stop.
nope, we'll get a couple more, we'll get like
Yeah,
2
I
more
think we
examples
should
done and then we'll stop.
because,
Find the probability of dying while making a skydiving jump. This is kind of morbid.
Do you have a parachute or
Okay.
not?
Yeah, we use a parachute.
Can I parachute you?
Well, everybody has a parachute, but sometimes parachutes don't open. So,
That's why they have
what
a-
happens
I don't
is,
have a parachute.
in recent years, there were about 3 million skydiving jumps, and 21 of them resulted in deaths. So, what are my chances of dying?
Is this real or fake?
7
This
to
is-
the minus 6.
21 over 3 million?
Yeah.
And you got 7 to the minus 6?
Yeah. Or 7 times 10 to the minus.
Was it 7 exactly?
Yeah.
Really?
Yeah. To the T.
7 times 10 to the what? Minus 6?
Yeah.
Okay, so that is a 0.000007. There's 5 zeros. Okay? Which, as a percentage, is how many zeros would you have if you converted it to a percentage?
Yeah,
3. You move it 2 places, so 0.0007. percent chance. Okay, so 0.0007% chance of dying.
What's your
Would you do it?
lottery?
I don't know. 21 of those people probably didn't have their parachute open, right? Okay. So,
Yeah,
The-
I skydiving by a lot.
The point of this right here, it says find the probability of dying while making a skydiving jump. Okay, the probability of dying. The only thing that we have to go off of is previous data. The previous data says that 21 out of the last 3 million have died. That's all we have to go off of to predict the future. So, probability of skydiving or of dying while skydiving 0.0007%. What?
I mean, if you jump off a bridge, you're technically skydiving.
I think they're doing like legit skydiving, like jumping from an airplane.
Like a
But
certain elevation.
Maybe you should
I
go
might
over
jump off
it
the bridge.
and see if they put
Right
it
on.
down
Yeah.
as a failed skydive
Yeah.
I don't
or
know.
a
I think
suicide.
we classify skydiving as using having to use a parachute.
Right. Yes, exactly.
One more
Having to use a
trash bag.
parachute.
Not a
Sure, you
Dude,
want
I got a
to
hood. I got a parachute. We're good.
All right. 3 children of the same gender. When 3 children are born, the same sample space of genders are shown. How many are there? How many different combinations could we have?
77.
8.
8. 1, 2, 3, 4, 5, 6, 7, 8. Those are the combinations that I have. If boys and girls are equally likely, then those 8 simple events are equally likely to happen. Okay? Assuming that boys and girls are equally likely, find the probability of getting 3 children of the same gender when 3 children are born. Okay? So how many of those 8 options have 3 children of the same gender? Boy, 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 and girl, 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 right? 2 out of 8, or 1 in 4 chance. So I have a 1 in 4 chance of getting all 3 boys or all 3 girls. Does that make sense?
Yup.
Okay, now let's talk about this for just a second. What are the chances of me getting
Why did I write my 4?
2 girls and a boy?
Still
That's what I have. I have 2 girls and a boy.
It's 1 out of
But
8.
2 girls and a boy, if they word it that way,
3.
not necessarily in that order, right? 2 girls and a boy, not necessarily in that order. So
So it's still the same percentage.
this one is 2 girls and a boy. This one is 2 girls and a boy. This one is 2 girls and a boy. What are the chances of me getting 2 girls and a boy?
3.
3/8. Okay? Does that make sense? So if I look at this on a chart, which is what we'll do later on, what we can have happen is we can have boys versus girls. I could have 3 girls and 0 boys, or 3 boys and 0 girls. I could have 2 boys and 1 girl. I could have 1 boy and 2 girls, or I could have 0 boys and 3 girls. That's what I could have happen. Okay? But a lot of people look at this. Hold on. A lot of people look at this and they say, I have a 1 in 4 chance of this happening, right? That's what they think. I have a 1 in 4 chance of this happening. I have a 1 in 4 chance of this happening, 1 in 4 chance of this happening, 1 in 4 chance of this happening, right? Because there's 4 different options there, okay? Now, what are my actual chances of getting a boy, 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 and no girls? What are my actual chances? 1/8, right? There's only one combination out of these 8 that's boy, boy, boy. Okay? How many combinations do I have that's 2 boys and 1 girl? 3 out of 8. How many combinations are 1 boy and 2 girls?
Still 3.
Still 3/8. How many combinations are 0 boys and 3 girls? 1/8. It is not 1/4, 1/4, 1/4, 1/4. A lot of people think that that's the case because there are 4 different combinations that I could get, right? So they're equally likely to happen. There are more combinations of 2 boys and 1 girl because I could have a boy and then a girl and then a boy, or I could have 2 boys and then a girl, or a girl and then 2 boys, right? So there are more combinations that split them versus, all of one and 0 of the other. If I take this guy and graph this thing, you know what it looks like? 1/8, 1/8, 3/8, 3/8, 1/8. It resembles one of these, okay? Which is what we're going to talk about next, okay?
Tomorrow?
So 1/8, 3/8, 3/8, 1/8. No, just wait. We're going to do one more example.
You just said that last time. We did this
We're going to do one more. We're going to do one more. One more.
Well, Katie, bring
Okay.
your stuff in. So you might want to look at it.
Texting and driving, last one. In a study of U.S. high school drivers, it was found that this many texted while driving, okay? When you're going through these and they throw out numbers, write them off to the side so you don't have to reread. So 3785 texted and drive. So we're texting while driving 3785 during the previous 30 days. And 4720 did not text while driving during that same time period. Based on these results, if a high school driver is randomly selected, find the probability that he or she texted while driving. So they want to know, yes, text while driving during the previous 30 days. So how many people texted while driving? 3785 out of a total, how many? 8505. And that probability as a decimal, 0.445.
0.445.
445. So
44.5%.
Make sure you check to see on the on your homework. They will probably have you write it as a decimal, or they might say a percentage, 44.5%. So be careful and look to make sure which one they are asking for. Yeah.
I'd rather do these
'Kay.
types of problems on paper.
Yeah, these ones are not too bad, right? This is like a good chapter.
I'd rather do this on paper.
This is like.
Oh, you'd rather do these on paper?
Yeah.
Okay. All right, everybody say bye, Holly and Kenzie.
Give yourself an